Hello. Welcome to navigating the service mesh ecosystem. Before we get started, I want to introduce the talk a little bit. So we'll get into introductions. My name is George. This is Diogenes. We are currently not working for companies that make products that are in this presentation, but we have both been very involved in the service mesh ecosystem, either by making contributions or giving talks, writing books or articles about the service mesh technology, how to approach it. And as a former engineer, one of the things that we've seen is a lot of interest in the service mesh and more products being introduced, and the enthusiasm is really good. There's a lot of uptake of service mesh technology, but with all of the enthusiasm comes a lot of questions and a lot of confusion around which service mesh you should use. And most of the time you see a presentation from a vendor that is talking to you about their service mesh and why that's the right one to use. So we thought we would do something a little different and give a talk that is vendor neutral, that looks at the different projects in the ecosystem and tries to give you as engineers the right questions to ask to figure out which solution is right for you. There's no one universal answer to that, and hopefully this presentation will help you figure out which approach is right for you. So with that, we'll do introductions. My name is George. I used to work at Buoyant. They're the makers of the Linkerd service mesh. I was director of community there. I'm now at a company called PagerDuty. I still do community there. All right, PagerDuty users. And so I do a lot of things like this. I work with a lot of users to help you figure out how to make infrastructure management better and easier to approach. And so hopefully this talk does a little bit more of that.
Yeah, thanks, George. So my name is Diogenes Rittori. As you can see, I'm not the same person from the picture. I have a little bit more hair than when that picture was taken. That's just kidding, it's still me. So I also been involved in the service mesh space for a while. I was able to give presentations, write articles, and while at Red Hat, I was a product manager on the service mesh capability of OpenShift, if you've heard of that. So very excited to be here talking to you. I also want to thank our sponsors, the companies that employ us and pay us the tickets to get here. So thank you, Solo, and I'm sure you're very happy to have PagerDuty sponsoring you as well here, right? And you've seen introductions to service mesh many times, and I think you've seen what is a service mesh. And as George said, we want to give you a different perspective on this, So we will talk about technical features of what makes a service mesh, but a somewhat different perspective. So this is the way I explain what a service mesh is, which is an application-focused network, right? I think the service mesh on purpose does not have the name network in it, then because you would have to deal with network faults, and it's always hard, right? So it's an application-focused network, and the features that the service mesh deliver, they exist to benefit the application, right? So they do not exist necessarily for the benefit of the network itself, but the capabilities that the service mesh deliver, they exist actually to benefit the application. So I'm going to invest some more time in addressing the needs of distributed systems. And that's an important point, because once you're dealing with applications that need to communicate, and once you're doing a process of breaking a monolith into individual microservices or into individual smaller applications, if you are doing that, you are in the realm or in the space of distributed systems, right? So I think, and I strongly believe that failing to acknowledge that you are in the space of distributed systems will bring you a lot of problems, right? So, and to present you some of the problems, I love talking about the fallacies of distributed systems. So these fallacies, which means they are all false, right, was created more than 15 years ago when people were starting to develop distributed systems, and they are still very valued today. So the first one is that the network is reliable, but then I was thinking that myself as a software engineer, I would always write code assuming that the network was reliable. That when I'm going to ask my application to connect or to integrate with another application, I assume that there would be a reliable network there. And that's not true. You know, networks are not reliable. Networks will go down. You will have a problem at some point in time. And the same can be said about latency, you know. So there is latency in the network. You don't have infinite ability to transmit and receive data. You don't have infinite ability to process data. So when you develop applications and you forget to acknowledge the fallacies of distributed systems, you will be in trouble. Right? So some of the others one that I especially find interesting is that the topology just doesn't change, you know? So you are writing an application assuming that you're going to connect to a certain database and you're referring to the database with the IP of the database. But in the development phase, it's one IP. And in production, it's a different IP. So just in that way, the topology has changed. The topology from when you were developing the application, it's different from the topology from when you're running the application, right? So again, acknowledging that the topology change, it's very important. You might think about service discovery then. You might think about externalized configuration. So again, it's important when you're developing applications to recognize this, right? Also, transport costs being zero, very, very important. And the service mesh technologies and the relationship that exists here, it's not, let's say, 100% precise, or you can't say that they're 100% one-to-one, the relationships that exist here, but I think there is some sense to that, to the relationships between the fallacies of distributed computing and the capabilities that a service mesh delivers, right? So just take, for example, the network is reliable. If I cannot trust on the network, then I will protect myself from that. I, the engineer of the application, I will protect. And how do I do that? I will think about adding maybe circuit breaking to my application, automated retries, some sort of load balancing so that the application can try to come to a trustworthy scenario without having to do much work, right? Again, network is secure. We all know the network is not secure. So why don't you think about making sure that the communication channels between the applications are encrypted. And that leads us to this very important point, which is that service mesh is not for you, right? We think, and you can probably go watch another session right there. So just leave the room right now and go watch another session, right? And the reason is that I think we fail to do the necessary engineer and architect work of making sense of things. So we fail to really do a proper analysis to see if we really need to use technology, right? Maybe this is a fashion industry, but I don't think it should be a fashion industry. I think there should be a need to use technologies. And one example is, can you name the name of all your services? Well, if you probably know all the services that you're talking to, that means that the number of services is not that big, right? You know, like 20, you can name 20 services, and that's all about what your application are going to interface with. Maybe service mesh is not for you, right? Maybe even Kubernetes is not for you, right? If your space is not so big. Another one, do you know how many times you deploy code per month? Oh, we do twice a month. Okay. Do you think it's worth the burden, extra complexity, extra managerial needs of a service mesh if you do deployments twice a month? It's important as architects and engineers to make that consideration, right? Because again, if not, we're just in a fashion industry. And
I think building on that, right, a good question to ask also when figuring out if the service mesh is right for you is when something goes wrong, when there's a failure, do you know which services failed and why? Is it very clear when something goes wrong where that failure occurred? Or do you have so many services that the interdependencies are very difficult to determine? If that's the case, right, if it's more complex, when something goes wrong, you're not really sure where the problem is, then maybe you actually have a need for this. But if the answer to this is yes, something goes wrong and I know exactly what failed, then maybe the service mesh is not for you. And then the most important question of all, right? Do you want to use a service mesh because it's cool, because it's great technology, and you want to tell your friends, I am using a service mesh because it's great? If the answer to that is yes, then the service mesh is probably not for you. And so what we're getting to, right, is that there's some very important work you need to do here to ask what problems you are having. Why do you need a solution like the service mesh? Do you have a lot of complexity? Are you in that distributed systems world, right? Are you running up against problems like having more than one administrator, or having a network that is not homogeneous, right? If you are having those issues, then maybe the service mesh is for you.
And they stayed, so this
and
is
they
the time.
stayed, right? So
yeah.
You didn't go watch another session.
Yeah.
So let's say that we've done that work, right? And we don't know how many times we've deployed in the last month, right? We can't name all of our services. We know that we have a very complex distributed application that we are managing. Well, then maybe you actually have a real problem, and then maybe at that point, a service mesh makes sense for you to use. But now, right, you know that you need a service mesh. It's a fundamental building block in a cloud-native stack. Which one do we use? And so that's the point of this talk, right? The idea is that we're going to look at the different options that are available in the cloud-native ecosystem. And there are a number of other service mesh options. We'll talk about those a little bit later. But today we're going to focus on the products that fall into the service mesh category that are popular when you're using Kubernetes or in the cloud-native ecosystem. We're going to go through this list historically in order of what project came along when. So we're going to start with Linkerd. And Linkerd has two versions, right? We heard Liz Rice on stage talk about version 2. We're going to look at Linkerd version 1. And the way to think about Linkerd v1 versus v2 is a little bit like Apache, right? There's Apache version 1 and Apache version 2, and they have different problems that they solve. They're different bits of software. It's not just an upgrade from one to the other. So Linkerd v1 has been around for almost 3 years as of February. It's tried and true, right? It's more than 1 trillion requests served in production. It's battle tested and used. But the way to think about Linkerd is because it was written 3 years ago, it was written in a time before Kubernetes was the de facto standard for container management platforms, right? It's back when DCOS was still a thing. Docker Swarm was a thing, right? We thought like that might work out. And so Linkerd is meant to be multi-platform. So the way to think about Linkerd is if you have services that you are trying to manage outside of just Kubernetes, then this solution might be for you. And when you look at Linkerd, right, Linkerd was the first tool to use the term service mesh for this category of tool. And for this category of tool, right, the things that you would expect are there. Resiliency features, latency aware load balancing, circuit breaking, retries, automatic TLS, very deep language for specifying how you do per route configurations. All of those built-ins are there, but here's how to think about Linkerd version 1. It's a very powerful solution, but it's also a very heavyweight solution. And so it's written in Scala, right, which means it needs a JVM to run. So the footprint of that can be pretty big. There's been some recent work to get it working on Graal VM and make that footprint a lot smaller, but it's still significant. So the reasons that you might go this route are, again, if you have a multi-platform use case or you need that type of complexity, you need all of those heavyweight features, then Linkerd might be for you and might be a place to start.
And now we go to Envoy, right? I mean, we've seen some talks on Envoy already. Envoy just yesterday or today was accepted to be the third project to move out of incubation in CNCF. So I think they will probably make an announcement soon on that. But again, it got the amount of votes needed to become a graduated project. And what I especially like about Envoy is that it it was not a solution looking for a problem. It was someone, Matt Klein at Lyft, that he had a problem on how to integrate and connect multiple services in a very performatic way, and he decided to create something, right? So it was created very much for the use case of Lyft, which is a ride-sharing company like Didi here in China, and and we go into the very purpose of this presentation. It's important to know the differences, right? So, for example, as let's say opposed or different than Linkerd v1, Envoy was written in C++, right? So that means that those that want or need to extend Envoy for whatever reason, they need to be able to do that in C++. And I think the reality is that there are probably more Java engineers or today that there are C++ engineers. So all those considerations have to be taken into account when you make the decision of choosing a technology, right? Also, interesting point about Envoy is that was created for a world without containers as well. It was created in a world for virtual machines. So the deployment pattern was that each virtual machine will have one service, and together in the virtual machine, the proxy will sit there. So it's like similar to containers, but instead of like one container per application, it will be like one virtual machine per application. Again, the project has gained a lot of popularity. It's a great technology, and it was extended. It was extended in many different ways. One of the ways that the project was extending is with Istio. So the engineers worked together to create extensible interfaces in Envoy that allow you to publish new rules to Envoy in a way that anyone that wants to do that, it's facilitated. Again, important point is that Istio, it's not necessarily and technically a a CNCF project, but I think it's fair to introduce it here, right? So Istio has a very, very strong development from Google, from IBM. There are other companies such as Red Hat, such as Pivotal that also participate in development, but it's very interesting to see how much engineering effort has been put by IBM and Google on this, right? So IBM was doing a similar project, I think called Amalgamate, and they decided to unite those projects into Istio and make into a single thing. And the table that I showed earlier pretty much talks about some of the Istio features and how they map to distributed computing, right? Istio has been evolving. I think it's fair to say that Istio is becoming a little bit complicated if you're just starting now. There are more than, if you know Kubernetes a little bit, there are more than 50 different custom resource definitions that you can use inside Istio to configure it to your liking. And again, the point, right? The extra complexity when dealing with service mesh has to be worth it, right? So if you're really willing to use a technology that is going to require more knowledge to manage and probably different people to manage, you have to make that decision. You can't just use without thinking about that. But again, Istio is great, so it does a great amount of work in generating certificates, in rotating and distributing those certificates for you. I mean, just thinking about the distribution of certificates in a non-scenario like this, where you would have to keep doing the manual rotation. So that's always a problem. And again, Istio does that. It works great, and it's been evolving pretty good.
And now we'll talk about Linkerd version 2. And it's interesting for me actually to hear this talk unfolding and historically how things have been introduced, because it makes a lot of sense for where Linkerd v2 has gone. And so if you look at the solutions before, right, we've been talking about distributed systems problems and all of the fine-grained features that you need to solve some of those challenges. But I think like we said in the beginning of the talk, not everybody needs all of that complexity. And so this is where I think Linkerd version 2 comes in. So Linkerd version 2 is a complete rewrite. There is no code from Linkerd v1 in v2. And what v2 was all about was looking at the lessons that were learned from running Linkerd in production. And what Buoyant discovered was that a large portion of customers were not making use of a lot of that complexity, right? There are a couple of common problems that you have right away, no matter how large your application is, when you start using distributed services and even containers on a small scale. And those problems tend to be observability. Ooh, whoa.
My fault, sorry.
Those problems tend to be observability, security, and performance, right? You want this thing to be fast. You don't want it to introduce any sort of latency, right? And that's why you see the proxying components written in Rust. They're very small, they're very scalable, they're very fast. And you see the features that are focused on, which is you get service level metrics. You can see what failures are happening, which exact service calls might be failing. And you get a lot of visibility into the session layer without having to encode that into your applications. The other thing that you get, automatic TLS, right? That certificate management, SSL upgrades, right? That seems to be a very common feature that has a lot of value. And the Linkerd v2 use case is centered around service owners, right? So it's very easy to incrementally adopt either by pod, right, or by service, and you don't have to deploy it across your entire platform, which means if you're not the only team using your Kubernetes installation, right, you can use Linkerd and talk to other non-Linkerd services. And you can do that incrementally, and you can do that easily. So it's really centered around what are the things you probably need first, and how can we make that easy to use? But the downside is, because it's zero config, because it just works easily out of the box, if you need a lot of that deep, powerful configuration, if you need features like custom routing, right, some of the things that are in the heavier weight solutions, it's not there. So easy to get started, but maybe not as powerful as some of the other solutions.
And there's an important point there, is that if you go to adopt, for example, Istio, there's not so much tooling around Istio today. You know, it's if you add, let's say, conflicting rules in Istio, like if you do like a route or a virtual service rule in Istio, that's going to conflict with a network policy in Kubernetes. Nothing is going to tell you that, you know. And so someone that controls the network in Kubernetes through network policies may have said namespace A cannot talk to namespace B, right? And then still in your Istio control plane or in your configuration, you're assuming that service A in namespace A can talk to service B. So that's why we make the point of you have to be really cautious about the decision of a service mesh. So Istio moved to V1 and a few months ago, right? So the tooling to facilitate investigation of problems in the usage of the technology itself, it's not there. There's not a tool today that will tell you exactly why a communication did not go through. You know, is it because of network policy that blocked? Is it because of a specific routing policy that was blocked? So all of that, you still have to kind of develop something yourself or do some manual investigation, right? Of course, we believe that the tooling will get there, right? It's just a matter of where we are right now in the evolution of the technology, right?
And I think that's an important point, right? Focusing on where you are, what problems do you need to solve most, and how much complexity is that worth to you, right? Again, all of these tools have a learning curve. There's complexity in maintaining them, upgrading them, understanding what happens when those tools themselves go wrong, right? So again, we're just looking at what are the different philosophies, where does each type of solution help you, and so hopefully you can use that to figure out which solution is right for you. But then the question comes up, all right, well, that's a nice look at those four. What about other service mesh options? And I think what we've seen lately is a number of additional solutions, whether it's Aspen Mesh or Kong, right, or a number of other vendors that are now playing in the service mesh space.
I see an Nginx shirt there.
Nginx
has something
right.
as well.
Yeah, and so the idea really is we only have 35 minutes today, so we're trying to cover as much ground as we can. We're looking at specifically what is mostly used in the cloud native ecosystem. But again, I think the things that you should look for are hints around which problems they solve and look at, does that match the pain that you are feeling with your applications today?
And with that, I think we want to, let's say, summarize this presentation by giving you a list of questions that you should be asking when you need or if you need to make a decision on whether or not service mesh is for you, and which service mesh technology is for you, or even can you do the same needs, or can you address the same needs with less technology, right? Because if you take Istio, for example, I mean, the default Istio, let's say, package comes with Prometheus, comes with Grafana. They just added Kiali. So you'll be bringing a set of tools that bring more complexity. So that has to be thought through, you know? So you should be asking yourself, the problems that you need to solve today, can I solve them without a service mesh? Is the solution sustainable? If it is, and if you can, then why the extra complexity? And I'm a big believer in service mesh, but I'm also a big believer in architectures that make sense, right? Architectures that are created in a way that they are sustainable and scalable, and not just, again, making this a fashion industry, right? I think you have some that you also have some thoughts about.
Yeah, absolutely. And so let me say this, not to be very negative about not needing a service mesh, right? I can tell you, if you are using containers, if you are using Kubernetes, you definitely have some of these problems, right? And one of the first problems that you have is what's happening at the session layer, right? When I'm making calls to other services, if they fail, do I know they're failing, right? Do I know why they're failing? Can I even tell that they're failing? And I think all of the different service mesh options help you solve at least that problem, right? Some of the other problems you might have, again, around managing security or consistency or some permissions around particular services, you should take a good hard look at what are the challenges that are facing you, right? And which problems hurt the most. Based on that, apply those to the different solutions, and you might have an idea of where to go from there, right? There are some other tactical ones, like which platforms you need to support, right? What functionality you already have. But I think a good one that we haven't talked about yet is who owns your services, right? Is that in the hands of developers? Do they need to mostly set permissions around how these services are configured, what they're talking to, and maintain control of that service communication? Or is that platform owners, right? Do you own your Kubernetes installation, or does somebody else? And I think one of those questions helps you figure out at least what type of configuration you want. Do you want everything centrally managed? Do you want distributed control over those things? And so hopefully you can start using this list to answer some of those questions for yourself.
I remember that while at Red Hat, I was doing an interview of a few customers that were interested in service mesh, and they would see the list of capabilities that a service has to deliver, and they would get excited. And then I asked, are you ready today to have two different versions of the same application running? So you're interested in A/B test. Does your CI/CD pipeline support having two different versions of the same application running at the same time? Well, the answer was no. We are not ready to do A/B tests, right? So, and then yet they were interested in going into the service mesh without, let's say, fixing the CI/CD pipeline first, right? So there is a lot of this needs to be thought through, and then this is just one example that came to my mind that I think it's very important.
Yeah, so a lot of things look really good on paper, but again, it's a question of what are you really going to use, what is critical to you right now, and maybe that can inform your decision. So with that, we're going to leave some more resources as well. There is a write-up that is on here that is a much longer version of this talk with a little bit more detail around those questions and additional places to probe. A couple of introductory books, both to the service mesh and to Istio. There's also a great talk, which is 4 reasons why you need Istio, which is actually looking more at the distributed systems problem. And so if you have other questions, we'll have a little bit of time for Q&A, I think still. Yeah, and of course we'll be around, and you can always reach out to us online. So thank you.
So we have a few minutes. If you have questions, you can ask. Yeah. Yeah. I can repeat the question.
As I know, Cisco announced a network service mesh. Yes, I think that it just fits the problem with the network training, yeah, to know that he can fix the connection and connection the tunnel for the application, yeah, not for network application. Just my opinion. What do you think?
I mean, I think there will have to be integration between SDN providers, whatever the SDN provider it is, and service mesh technologies, right? Because when network policies, which is a great technology, was thought through, it kind of a little bit can be conflicting with service mesh. I think another way of seeing this is who created the technology, right? So the technology created, the Istio technology was a lot of contribution from Google, and Google essentially likes to use what they call flat network, where all where all computers in the network should be able to communicate with all computers, but applications not necessarily. So the network access is available, but then there is a certificate between every single application that needs to talk to. So it's a different way of thinking about. So you, like the way Google would think about it is like the network is open, all IPs are available, but you actually protect the application, right? And the way network policies was thought through is more like networks are, that you have a firewall, in your firewall you decide which services can talk to what services. So I think there's this integration that still needs to happen in the technology to make sure that the rules of your network will be consistent with the rules of your service mesh. And it's technologies, it's doable. So I think I think it's not there yet, but it will have to get there. You know, customers will need that. They already do need that. Yeah. Thanks for the question. Yeah. Yeah.
Hi, we're actually building a multi-cluster infrastructure. So my question is how to set up the pod level or service IP level connectivity with Istio a native solution. Do you have any clues on that? Thank you.
I think if you want to introduce service mesh to that, there's a few things that are being thought through, at least in the Istio, with zone gateways, which is just like border gateways that have been used forever. You have a border gateway between the multiple clusters, and you share this space where the services are registered, right? So in a multi-cluster, if you want one service in a cluster to talk to a service in another cluster, both clusters have to know what services are available, right? So the solution has to be a centralized service discovery, and there are great solutions for that. Consul, for example, from HashiCorp, it's a great solution for that. But then I think you have to think about doing egress and egress properly. And last I checked, Istio Group was doing work on the gateways, the zone gateways, or multi-cluster gateways. Yeah.
So to answer your question, in a Linkerd world, there's just a simple proxying component that you put in front of every pod, right? And the interface for that pod is that proxy, right? It's transparent to every other endpoint. So as long as you expose it, right, you can talk to any other service, you can connect it. It's a very simple approach, right? But it's one that's very easy to compose.
Yeah, I think
we have 2 minutes. We have time for maybe one more question.
Have you tried Console Connect?
The question was, have we tried Console Connect? I have not tried Console Connect.
Yeah, I have myself not tried Console Connect. I sense a diminished investment in that technology. So.
Was that a question or a statement?
It was kind of a statement that I'm not so sure about. Can I, because I have very strong opinions on that.
Well, the question was, do we see a world where service mesh technology will get consumed into API management solutions?
I see the other way around, and that's why I say I have very strong opinions on that, is that if the API management solutions don't start thinking about it, their business are going to go away. Because rating and limiting, it's there, right? So you add a decent developer portal with billing on top of a solution that already does rating and limiting. It's somewhat of okay of an API management solution, right? And I say this is because the folks at least that I know that work in API management solutions at Google, they are the same kind of group that also work on service mesh. So I think they will become the same thing, or they will cease to exist. Or our API manager will cease to exist. That's a very strong opinion on that.
And with that, I believe that brings us to time. So thank you very much for your time.
We can take questions
Yeah.
outside. Yeah.
Thank you.